Good day. Welcome to chemistry class. Your tutor is Dorcas Hadebi. I'm a chemistry tutor. I love to teach chemistry. I've taught many students chemistry and it's been excellent all the way. Let's get back to class. Today's topic is redox reaction. Follow me through the class. Lesson objectives. At the end of this lesson, you should be able to define oxidation and reduction, relate oxidation number and how you pack naming, identify oxidizing and reducing agents, balance redox equations. Redox reactions. What is the meaning of redox? Redox is obtained from two words, reduction and oxidation. The word reduction is shortened to red, while oxidation is shortened to ox. And from those two words, we have redox. The word redox reaction is obtained from the words reduction and oxidation reactions, like I said earlier. What then is a redox reaction? A redox reaction is one where oxidation and reduction reactions occur together in the same reaction. So when we have a particular reaction with oxidation and reduction reactions occurring simultaneously in the same reaction, then we call such a reaction a redox reaction. Now we want to define the terms oxidation and reduction. And we have several ways of defining the terms. Okay? So I'll be starting with the definition in terms of oxygen. Oxidation is the gain of oxygen. Oxidation is the gain of oxygen. While reduction is the loss of oxygen. Reduction is the loss of oxygen. Let's take a look at this equation. Let's start from the reactant, carbon. Okay, so carbon is one of the reactants here, and taking a look at carbon on the reactant side, it's now been transformed to carbon 4 oxide, CO2, on the product side. Okay, we have carbon 4 oxide on the product side. That means carbon has gained oxygen atoms. Carbon has gained oxygen atoms, and we call that oxidation. The gain of oxygen is known as oxidation. Let's take a look at another reactant, zinc oxide. Zinc oxide is another reactant in this equation. Okay, the zinc oxide has now been transformed to zinc on the product side. That is ZNO has been transformed to Zn on the product side. That means zinc oxide has lost oxygen atom. ZNO has lost O. It has lost the oxygen atom, and now it is just Zn. And we are going to call that a reduction, because reduction is the loss of oxygen. Okay, let's take a look at oxidation and reduction in terms of hydrogen. Oxidation is the loss of hydrogen. Oxidation is the loss of hydrogen. While reduction is the gain of hydrogen. Reduction is the gain of hydrogen. Let's take a look at this equation. One of the reactants is hydrogen sulfide, H2S. Okay, H2S is on the reactant side, but on getting to the product side, it has been transformed to give S, to give sulfur only, sulfur as an element. Okay, that shows that hydrogen sulfide, H2S, has lost hydrogen atoms. It has lost H2, the hydrogen there, okay, to give sulfur only. and that is known as oxidation, because oxidation is the loss of hydrogen. Okay, let's look at chlorine atom on the reactant side. That's another reactant in this equation. Chlorine atom has now been transformed to hydrogen chloride, HCl, on the product side, showing that chlorine has gained hydrogen. It has gained a hydrogen atom, okay, and the gain of hydrogen is known as reduction. Reduction is the gain of hydrogen. Let's take a look at oxidation and reduction in terms of the addition of electropositive or electronegative elements. Before I go into the definition, I would like to expatiate more on the terms electropositive or electronegative elements. When they talk about electropositive elements, they are usually elements that love to donate electrons, such that at the end of the day, as an ion, they will carry a positive charge. And that is why they call them electropositive elements. So a good example of that is metals such as sodium, potassium, calcium, magnesium, aluminium, and so on. Okay? While electronegative elements, they are the elements that love to gain electrons. They love to gain electrons, such that at the end of the day, they become negatively charged. Example of such elements are the non-metals. A good example of that is chlorine, oxygen, fluorine, and so on. Okay? So let's take the definition of oxidation and reduction in terms of the addition of electropositive or electronegative elements. Oxidation is the gain of electropositive elements. Oxidation is the gain of electronegative elements. It is also the loss of electropositive elements. Oxidation is also the loss of electropositive elements, while reduction is the gain of electropositive elements. Reduction is the gain of electropositive elements. It is also the loss of electronegative elements. Reduction is also the loss of electronegative elements. Let's take a look at this reaction. We have sodium on the reactant side, but on the product side, it is now sodium chloride. Okay, what has happened? Sodium has gained chlorine atom. Okay, sodium has gained chlorine atom, and the chlorine atom there is electronegative. Okay, so that's the gain of electronegative element, and that is known as oxidation. Okay, so let's take a look at chlorine. Let's look at chlorine atom on the reactant side, which has now been transformed to sodium chloride on the product side. Okay, so chlorine atom has been attached, or it has gained an electropositive element, which is sodium. It has gained electropositive element, which is sodium, and that is known as reduction, because reduction is the gain of electropositive elements. Okay, let's take a look at oxidation and reduction in terms of electron transfer. Oxidation is the loss of electrons. Oxidation is the loss of electrons, while reduction is the gain of electrons. Reduction is the gain of electrons. Let's take a look at this reaction. we have iron 2 chloride, FeCl2, as one of the reactants, okay? But it has now been transformed to give iron 3 chloride as the product, meaning that iron 2 chloride, FeCl2, has donated an electron, that is, it has lost an electron to give iron 3 chloride, alright? And that is going to be an oxidation reaction because that's a loss of electron, okay? So let's look at chlorine atom. Chlorine atom has now been attached to chlorine atom has now gained an electron from iron. Chlorine atom has gained electrons from iron such that chlorine is now iron 3 chloride, and the gain of electron is known as reduction. Okay, at this point, I would like to emphasize the importance of learning to write the half ionic equations of each reactant or of each reaction. Okay, so of each oxidation reaction and reduction reaction, that is what we know as half ionic equations. Okay, and that's what I'll be talking about now. Okay, so we can see the first ionic equation, the first half ionic equation, which is the oxidation equation that is written here. Okay, so we have iron 2 ion, Fe2 plus, which has lost electron to give iron 3 ion, and the loss of electron, like we said, is oxidation. Okay, but in chemistry, it should be noted that usually we add electrons or mixtures or compounds together. It's rare to say we are subtracting them. So with that notion, I would like you to know that it is not often written. The first equation I wrote here is not usually written in chemistry. So we rather go for the second half ionic equation, which is iron 2 ion, Fe2 plus, going to Fe3 plus 2E minus. Okay, so the electron has to be on the other side so that it can carry a sign of a plus rather than a minus. Okay, let's take a look at the second half ionic equation, which is that of chlorine. Okay, so chlorine atom has gained electrons to give chloride ion, and that is known as reduction. Okay, now let's learn oxidation and reduction in terms of oxidation number. Oxidation occurs when there is an increase in oxidation number. Oxidation occurs when there is an increase in oxidation number, while reduction occurs when there is a decrease in oxidation number. Reduction occurs when there is a decrease in oxidation number. So what is this oxidation number we are talking about? The oxidation number is usually assigned to elements based on some certain rules. Okay, so let's get started. We have this equation. Okay, we have this equation and we want to assign the oxidation number of each element present. So we start with zinc. The oxidation number of zinc is 0. Why? Because it is in its free state. Free state in the sense that we don't have other elements attached to it. Okay, so copper is 2 plus. So we learned more about how to calculate the oxidation number of elements. So the oxidation number of copper is 2 plus, while that of sulfur is +6. That of oxygen is -2. Okay? Why zinc? I've moved to the product side now. I have zinc sulfate. Zn is 2+, S is +6, oxygen is -2, and copper, because copper is in its free state, is carrying a charge of an oxidation number of 0. Okay? So you should note that while you are considering oxidation and reduction reactions, whichever elements that remain the same, they are not considered. That is, if the oxidation number remain the same, you will not consider them. Take for instance, you can see sulfur on the reactant side is +6. Then on the product side, it is also +6. Okay? Oxygen is -2 on the reactant side, and it is -2 on the product side. So we will not consider that. Okay, so let's try to identify the oxidation and reduction reactions now. So you can see zinc, Zn, is 0 on the reactant side, but on getting to the product side, it is now 2+. Okay, so that's an increase in oxidation number, and we are going to call that oxidation. We are going to call that oxidation. Okay? Let's take a look at copper. Copper is 2+ on the reactant side, and on getting to the product side, it is now 0. That's a loss or a decrease in oxidation number. That's a decrease in oxidation number. Then we are going to call that reduction. Okay? Let's now learn the rules for determining oxidation number. The rules for determining oxidation number. Rule 1. The oxidation number of an element in its free state is 0. The oxidation number of an element in its free state is 0. Rule 2. The sign and charge on an ion or radical is its oxidation number. So what's an ion? An ion is a charged element. So if you have an element carrying a charge, then you call that an ion. Example is Na+, sodium ion. You could have Cl-, chloride ion. Okay? Then what is a radical? A radical is a group of elements that is a compound with a charge. Is a compound with a charge. Example is SO4 2-. Okay? So let's get back to oxidation number. The rules for determining oxidation number. The second rule is that the sign and the charge on an ion or radical is its oxidation number. So the oxidation number of Mg2+, magnesium ion, is 2+. The oxidation number of Mg2+ is +2. Okay? While the oxidation number of the radical MnO4- is -1. Okay? Rule 3. The sum of the oxidation number of all elements in a compound is 0. The sum of the oxidation number of all elements in a compound is 0. Okay? That is, the total number of the oxidation numbers in a compound is going to be equal to 0. So we learn more about these rules. Calculation of oxidation number. Example 1. Calculate the oxidation number of magnesium Mg in MgCl2 in magnesium chloride. Solution. We are looking for the oxidation number of magnesium, it is unknown. Okay, while that of chlorine is -1. How did I get -1? Okay, so among the first 20 elements, chlorine falls to number 17. So if I'm meant to fill that 17 electrons on the shells, then I'm going to have, in the K shell, I will have a 2. In the L shell, I will have 8. Then in the M shell, I will have 7. Okay, the M shell can take a maximum of 8 electrons, meaning that chlorine needs 1 more electron to fill its shell completely, and that is why it is carrying a charge of -1. It's minus because it's going to gain that electron, and when an element gains electron, it carries a charge of a minus. Okay, and the number of electrons it needs to fill it up completely is 1, and that is why the oxidation number of chlorine there is -1. Okay, let's proceed. So we now have Mg plus -1 times 2. The 2 is coming from the 2 atoms of chlorine. Chlorine has 2 atoms. Okay, so that's going to give you -1 times 2 equal to 0. So we equated it to 0 because we followed rule 3 of the rules for determining oxidation number. The rule 3 says that the sum of the oxidation number of all elements in a compound is going to be equal to 0. This is a compound and not a radical. It's not a radical because it's carrying no charge. It has no charge on it, so it is a compound. Okay, and the sum of the oxidation number in a compound is going to be equal to 0. Okay, so we are going to solve it mathematically now. We have -1 times 2, that gives -2, times plus -2 times plus, we give a -2. Okay, so we have Mg -2 equal to 0. Now we need to make Mg, magnesium, the subject of the formula. We now have Mg equal to +2. Therefore, the oxidation number of magnesium in magnesium chloride is +2. Kindly note that the sign plus or minus, whatever answer you obtained while calculating your oxidation number, be it a positive sign or a negative sign, must be included while writing the oxidation number. Okay, and that is why I wrote Mg equal to +2. I didn't write Mg equal to. If I've written that, that would be wrong. It has to be Mg equal to +2. Then if I had a minus, I must include that minus in the final answer. Example 2. What is the oxidation number of iodine in iodate ion? What is the oxidation number of iodine in iodate ion? Solution. So we are looking for the oxidation number of I. I is unknown. Then I want to represent I with a Y now. So I'm representing I with Y. Okay. The oxidation number of oxygen is -2. Why is it -2? It's -2 because oxygen has, in its valence shell, it has 6 electrons. It actually belongs to group 8 to number 8. It belongs to number 8 among the first 20 elements, and it belongs to group 6. Okay, because we have 2,6 while filling its shells. So the K shell has 2, while the L shell has 6, and that's why it belongs to group 6. So it needs 2 more electrons to fill up its outermost shell. It needs 2 more electrons to fill up its outermost shell, and that is why we have a -2. But it's going to gain that electron, and while gaining the electron, it has to carry a sign of minus, and because it has 2 electrons to gain, it's now -2. Okay, We now have to substitute that into the compound, okay? Y times 1, that is iodine times 1 atom of iodine, plus minus 2, the oxidation number of oxygen, times 3 atoms of oxygen, okay, equal to minus 1. And why is it minus 1? It's minus 1 because it is a radical. A radical is a group of elements with a charge. It's carrying a charge, and the sum of the oxidation numbers must be equated to the charge, and the charge is minus 1, though the 1 is hidden. They didn't write the 1, but because it is hidden, it shows that its oxidation number is a minus 1. Okay? Now let's solve mathematically. We have y plus minus 6 equal to minus 1. Alright? We now have y minus 6 equal to minus 1. Now we need to make y the subject of the formula. So we either add 6 to both sides, or we bring the minus 6 to the other side. Okay, and now we are left with y equal to plus 6. And therefore, the oxidation number of iodine in iodate ion is plus 5. IUPAC nomenclature. The IUPAC nomenclature is a type of naming which involves the calculation of the oxidation number of at least one of the elements while naming the compound. IUPAC nomenclature is a type of naming which involves the calculation of the oxidation number of one of the elements while naming the compound. Okay? Let's take a look at this example. We have to give the IUPAC name of K2CR2O7. That's potassium heptazochromate 6. But how did I get that name? Let's proceed and find out how to get the IUPAC name. Okay, we have K2CR2O7. So like I said, we need to find the oxidation number of at least one of the elements. And usually the oxidation number of the elements we do look for is the middle element, especially when you have 3 elements. When you're having 3 elements together, then you need to look for that of the middle element. So the middle element here is Cr, chromium. So we want to look for the oxidation number of chromium. Okay, while you are looking for the oxidation number of chromium, you need to find the oxidation number of all other elements present while you look for that of chromium. Okay, let's get started. So the oxidation number of potassium is plus 1. How? Potassium belongs to number 19 among the first 20 elements. Filling its 19 electrons in its shells, we have the K shell has 2, the L shell has 8, the M shell has 8, then the N shell has 1. Okay? So, potassium wants to have an octet structure. Therefore, it can easily lose its 1 electron that is found in its valence shell. So, it can easily lose that 1 electron to give a plus 1. It's plus because it's actually donating the electron. It's losing the electron. It carries a charge of plus, and it's 1 because it's releasing just 1 electron. Okay, times 2. That's the number of atoms of potassium. We have 2 atoms of potassium in that compound, and that is why we are multiplying by a 2 plus 2 Cr. Okay, that's 2 times Cr, 2 atoms of chromium, plus minus 2. We know why the oxidation number of oxygen is minus 2 now, times 7. 7 is the number of atoms of oxygen there, equal to 0. So we are equating to a 0 because it is not a radical, rather it is a compound. and for a compound you equate it to 0, while for a radical you are going to equate it to the charge. Alright, we now have 2 plus 2Cr minus 14 equal to 0. Alright, so you need to collect the like terms, and doing that you now have 2Cr minus 14 plus 2, and that's going to give you 2Cr minus 12 equal to 0. Alright, so we have 2Cr equal to 12. So we need to make Cr the subject of the formula. So we need to divide both sides by 2. And doing that, we have Cr equal to 12 over 2 equal to plus 6. Okay? So in naming this compound, you name the metal first, then the non-metal, then the middle element with its oxidation number in brackets and written in Roman numeral. Alright? So we name the metal first. The metal is potassium. Potassium. Hepta. Hepta is obtained from O7, 7 atoms of oxygen. So hepta is the word we use for 7 in chemistry. Why numbering and we have a 7, we call it hepta in chemistry. Okay, oxo, that's the shortened form of oxygen. That's the short form of oxygen. Then chromium will be converted to chromate because it's not in a compound. It's not on its own. Okay, then we need to put the oxidation number in a bracket and write it in Roman figures. Alright, so we now have potassium, hepta, oxo, chromate 6. Okay, we have these exercises from past questions, really, WAEC questions. Please attempt them. Send your answers to the comment section below. Okay, just click the comment section and send your answers. Okay, kindly like, share and subscribe. Please kindly like this video. If you enjoy it, please like it, please share it to your friends and subscribe to this channel. If you have not subscribed, click the subscribe button and turn on the notification bell. Alright, so for your home tutorials, for your home and private tutorials, kindly contact me on the number displayed here, 09064319129. In the next class, I'll be considering identification of oxidizing and reducing agents and balancing of redox equations. Okay, thank you very much. God bless you. Thank you.